In this video, you will be learning to build AI agents using LangChain, and I'll walk you through the exact steps that I took for building a job application agent. And while we are learning to build an agent, I'll also introduce you to frameworks like LangChain and LangGraph, and we'll talk about AgentState and memory in agents, and we'll also learn about middleware in agents. By the end of this video, you'll not only know how to build an agent, but also you'll have very good conceptual clarity on the concepts revolving around agent, which very few people know about. So before we start, let's take a look at the job application agent in working state. So I'll start by running the server. After you run the server, you'll see this screen. Then you can upload your resume here and then provide the job role and the location that you're looking for. I'll choose AI engineer in Berlin and on LinkedIn, and then click find jobs and analyze resume. And then it starts finding the jobs. Okay, now it's analyzing the resume against all the job descriptions. Currently, I've limited this job application agent to 3 jobs, but you can change that parameter in agent.py and just search for the word limit, and you can update it for respective platforms. Once the job application agent is done, you'll see that it will list down all the jobs that it has found so far, and the resume tailoring suggestions will be here. And as you can see, it says the agent is paused waiting for you to review these suggestions. This is basically the human in the loop middleware that I'll talk about when I walk you through the code on how I've added it. But this is for a human to review in between the agent is working. So after you approve it, so here we have like 3 jobs, so 3 different resume suggestions. After you approve it, and it is gonna again run for some time. So you can see it's again saying that it's working. So it basically went back to the agent and doing rest of the things that it needs to do basically. And now you have 2 different options. One is download tailored resume. So if you click on this resume will be downloaded, and if you click on this apply button, a new window will open. It will actually take you to this job, and then I can click on apply for the other jobs. I can download the tailored resume version and then apply, and then there is a agent summary which tells me what really happened behind the scenes. There it created tailored resumes, the files are stored here, and yeah, this is your job application agent. I hope you're excited to build and use the job application agent. So without further ado, let's get started. To begin with, let's first understand what an AI agent is. AI agent is basically LLM plus harness. Harness word in English actually means to control something in order to use its power. So what we are trying to control is the LLM, which is the model. And what is the power of those LLM models? It is to predict the next most probable token, right? So harness is basically everything around the model that you do so as to multiply its power, right? So for example, prompt is harness, right? Then memory is also an harness that you provide to LLM so that it's able to come up with much better responses. Then tools can be harness. If you give LLMs access to external tools so that it's able to get relevant information before it's answering the questions, then that is also an harness. So anything that you do around the model so as to multiply its power is harness. So LangChain is the open source framework which actually provides you with those harnesses for LLMs, right? So in LangChain is generally preferred when you already know the sequence or chain of events. For example, RAG is one of the very good use cases for LangChain framework. So the next point is that LangChain agents are built on top of LangGraph. So because we'll be building agents using LangChain and it's actually using LangGraph internally, I would like to take some time to give you a sneak peek on what LangGraph is. So LangGraph is basically a lower level orchestration framework which is used for building agents or much more complex workflows. So by that I actually mean that it gives you much more control over your agents. So if you have, let's say, multiple agents, then you can orchestrate it much better if you're using LangGraph, because in LangGraph you'll be actually creating agent nodes, tool nodes, and you'll be maintaining or managing the state explicitly, which is generally managed in LangChain implicitly. But also you can customize agent state in LangChain as well, which we'll see as we go through this video. Building the job application agent. But in general, if you are doing some production project, it's generally preferred that you start with LangGraph and not LangChain. LangChain is generally preferred for prototypes, right? So again, LangGraph, as the name suggests, is based on the graph data structure, wherein all the nodes are either agent node or tool node, and the edges actually demonstrate the transitions between agent node and tool nodes. And then there is a state which is shared between all of the nodes to understand what is the state of the agent at a particular time. So a basic difference between LangChain and LangGraph is that LangChain is a sequence of events, and it's actually a directed acyclic graph, whereas LangGraph is a stateful graph which maintains the state and has agent nodes, tool nodes, and edges demonstrating the transitions between those nodes. Okay. So before we actually start building a job application agent, let me give you a quick high level on what the job application agent is doing. So when you have to create a job application agent, you basically need three things on a high level, which is you need it to find a job by scraping it from somewhere, or you use some MCP server to get the tools for finding the jobs, or the second thing is that you need a resume analyzer which will take your resume, then compare it to the job descriptions, and find the gaps and tell you make this change, make that change. And then the third thing is that after you have reviewed the changes, which is basically what the functionality of human in the loop is, that you review all the changes that the agent is suggesting for your resume, and then go and apply to the job. So this is just the high level. Now let's get back to actually building this agent. So I'll start with creating an agent. So for creating an agent, LangChain provides this method, and you can just call this method and provide all the details like system prompt, tools, model that you want to use, state schema, which is your agent state, check pointer is the memory, which we'll come to in some time. Middleware is the human in the loop middleware that I talked about. We'll also understand what middlewares are, etc. So everything you define it in this create agent. It is as simple as that. So once you're done with creating the agent, then you can actually go and start defining the tools that we talked about, which is a job finder tool. You'll need a resume analyzer tool and a apply to jobs tool, right? So if I talk about the job finder tool, going to a platform that you provide basically in your prompt, and it will take in the role, the city, the radius that you want to search in, again all from your prompt, and try to scrape the jobs from Stepstone. This is one of the platform for finding jobs in Germany. Default, if you don't provide a platform in your prompt, then it will default to LinkedIn. uh, and if you go and see the code for the scrape LinkedIn jobs to CSV, you will see that I'm just making a call to a MCP server which goes and finds jobs from LinkedIn. You can also add in more platform support here. You can add Indeed or any other platform that is supported in your country, and otherwise it will just default to LinkedIn. And the important things when you are defining a tool is basically this @tool decorator that you have to put for agent to recognize this particular function as a tool, which is actually coming from LangChain.tools library. And the other important thing is the uh, name of the tool. It should be very clear and specific so that agent is able to know that it needs to invoke this tool for finding the job. So it should be very explicit. And the doc string that you need to define here for the tool should be very clear and precise on what this tool is doing, which also actually helps the agent to understand if it needs to make this tool call or not, right? Then there is tool message, which is used by the agent once your tool has completed the run. So that is why you will see with every tool message we have to provide a tool call ID, which is coming from the runtime, because this job finder basically scrapes the jobs from some platform, let's say LinkedIn or Stepstone, and then puts all the details into a CSV file, which basically has like the title and job details and everything related to the job. So this particular tool is also returning the CSV path. So how it returns it and how this travels, we'll talk about when I talk about it in the agent states. Next tool is the display jobs tool, which is doing nothing, just printing the title, company and location from all the jobs it has gathered. Then there is analyze resume and make suggestions tool, which if you take a look closely, you will see that there is a LLM call being made for this one, because you will see that it's going to each of the row with the description and asking the LLM to come up with the gaps that are there in your resume versus the job description and tailor it to that, right? Then it just appends those resume corrections in another column, and again sends back a tool message which will go to the main agent so that it knows that what is the next step, what it has done so far, what is the output of the tool that it needs to use, and so on and so forth. Right. Then there is the apply jobs tool that I've just hard coded here, saying that apply to all the jobs. You can definitely add more functionality here so that it actually goes to the links that are provided in the CSV and start applying to the job with the resume suggestions that it made, right? Memory is basically agents being able to remember past interactions, right? So there are two different types of memory in agents. One is the short term memory, the other is the long term memory. Short term memory enables your agent to remember past conversations in the current run, or you can say that it is persisted in a particular thread, right? Whereas the long term memory is something that is actually stored in a data store, and your agents are actually able to remember conversations even beyond the current run. So any conversation that happened in past, uh, agents will be able to answer better just by restoring some information that it has stored from past conversations in some data store, and be able to answer you better. So for example, it can store, like if you consider the job application agent itself, and if you have a long term memory, then it will store somewhere in their databases saying that okay, this user has a preference for AI engineer in Berlin, and it will give you suggestions based on that even if you don't provide it in the prompt. So that is long term memory, whereas in short term memory you will have to provide all these things, because it won't be able to remember anything apart from the conversation that is happening right now. LangChain's agent manages short term memory as part of AgentState. We'll come to AgentState in some time. And the short term memory updates when the agent is invoked or a step like tool call is completed. So, this is very important. So, if you see here, when you're defining the memory, you're using something like checkpointer. So, checkpointer basically tells the agent that it needs to create checkpoints after certain states changes. Whenever the LLM is invoked, there's a state change and a checkpointer is created. That is how agents are able to remember, right? That is how it's able to persist the conversations. Whenever there is a tool call, that's also a state change. Tool has returned something new, etc. So again a checkpoint is made. So that is how memory is creating checkpoints as the state is changing. So because we have talked so much about agent state, it's time to define what is an agent state. An agent state actually contains all the messages that you have had so far with your chat assistant, or results from different tool calls and so on and so forth. So all of that is maintained in the agent state, and it keeps on changing as your agent keeps on executing, right? So every time there's a change, or every time there's a result you get from some tool call, all of that is called as a state, right? So for example, here I have customized the job application agent state, which has two different variables, which is path to job CSV and PDF base 64. So at the start of the agent, you will see that both of these are none, and when you provide your resume, that is converted to a base 64 format, and this variable is assigned to the resume content. So that can be called as one state. And path to job CSV is, let's say, updated after the tool call, which is the job finder. So that is another state. After you have included a custom state, you can actually define it here in the state schema while you're creating your agent. Now there is another important thing that we need our job application agent to do, and that is to involve a human who can actually review the changes that have been suggested by the LLM to make to your resume before we actually go on applying to the jobs, right? And how do we do that is through a middleware. So middleware, you can think of it same as how we have middlewares in web applications. Like we have authentication middlewares which interrupt your normal client to server request flow and goes and authenticates the systems, or does some logging. So the middlewares can either be pre-built middlewares which are already provided by LangChain, like the ones that you see here on the screen. The one that we are using in the demo is the human in the loop middleware, which basically pauses execution for human approval of tool calls. But you can also build your own custom middlewares by providing a hook. It can be either before agent, before model, after agent. So how do we define middlewares is we go to this create agent and define all the middlewares that we need for that particular agent. And here we have the human in the loop middleware, and it says interrupt on apply jobs is true. So basically apply jobs is one of the tools, and if you look at the definition of human in the loop middleware, it basically implements the hook after model. So this will run after there's a message from AI, and if that AI message includes a tool name which matches this apply jobs, then there will be an interrupt. Then basically the agent execution will pause. So now let's go and invoke our agent, and meanwhile it's running, you can see that here I'm providing a config which basically has a thread ID. If we don't provide this, then our checkpointer in memory will not work, so we need to provide it. And here are the messages and the PDF file that we uploaded, and this is basically invoking the agent with the human message which says find jobs for AI engineer in Berlin on Stepstone. You can actually go and see how LangSmith is running it, and let's learn to trace it in LangSmith as well. So this is the current run that is happening. You can see that it invoked the job finder tool and the job display jobs tool. You can go to this and see what was the input, what was the output. Then you can also see that it invoked this tool, and then you can see that it invoked this human in the loop middleware. So if you will see, it says that interrupted, right, because we added a human in the loop before it actually starts applying for the job, right? Someone needs to review this suggestions on the resume and then start applying to the jobs, and it has worked the way that we wanted. So you can see that this cell completed execution. So now what do we do is we actually go and catch that interrupt and provide it with a decision that you approve of it or reject of it, and agent will take the action based on that. And this is how you do it, and here I'm just approving it and I'll just run it. Okay, now that it was able to handle the interrupt, you will see the final response from the AI agent, and it says here's the status of your job search and initial application flow, platform was this, role blah blah blah, and then jobs found was this, resume updates, I generated tailored resume suggestions which is saved here in the CSV, and these are the proposals and require approval, applied to jobs, status applied to all the jobs. So you can see that it executed through the flow as expected and was successfully able to go to the relevant tools that it had to for finding jobs and then updating the resume and applying to the job. All the link to the code is in the description, and you should always start with building a single agent. That was my learning, because if you start directly with multiple agents, it's very hard to follow up on the agent state, what is runtime context, how is the memory being managed, and all of that. So it's better that you start with a single agent, make it working, and then jump to multi-agent system. So next video, part 2 of this, I'll be showing you how to build a multi-agent for the same job application agent. We'll try to break it down into two different agents and show you how that works in LangChain. So stay tuned. I hope you got to learn something from this. See you in the next one.